Let me explain. Okay. So, tomorrow's your test on 4547. Because it's the first one of the semester, we're collecting homework from everybody. Okay? So what we're doing is we are collecting these 4 things. Okay? Now, we'll start at the bottom. Okay? The cotangent and cosecant graphs. Most of you have already turned those in already. They're already graded. That's pretty much the only grade in the grade book, at least in my grade book. That's the only grade one in the grade book. Okay? So that one's due, that was on your own sheet of paper, etc. Okay? Next one up is the 4.7 formative assessment. That one was green. Okay? Most of you have turned that one in also, just haven't necessarily graded them and put them in the grade book. Mrs. Hill I dropped off papers to her last night, so she just got them, so she's probably going to go through today and put them in the grade book today. Okay? The 4.5, 4.7 review packet, that's the one that you got on Friday. That's the 4-sided one. That one has the staple on it. It's got 4 graphs on the front, then some composition and some other fun stuff on the next 3, and then some ACT stuff on the back page. Okay, so there's that one. Then the 4.7 worksheet is the single-paged worksheet one. The packet 4.7 was the notes on you discovering the tangent graph and inverse tangent. Okay? The 4.7 single page has like 20-some inverse trig functions and composition trig functions on the front, and 4 of them on the back with some ACT questions on that too. Okay? So those 4 are due tomorrow. Steel pipe lab, which you did yesterday in class, that's due by Friday from everyone. Okay? Most of you have turned that in because most of you got done with it in class yesterday. Okay? So those 5 things are due in the next 2 days along with the test. The test tomorrow is 1 sheet of paper front and back. Okay? It should not take you the entire hour, but we're giving you the hour just in case. Just in case. I full on expect everybody to be done by it within half an hour. Okay. So, what is on that test for tomorrow? Well, these topics are going to be on it. First off, you will have to graph one of the 4. So you need to know how to graph all 4. Okay? You also will need to know, you'll have to identify some of the other ones too. So 1, you have to graph it, and I think there's either 1 or 2 where you have to identify what it is. Okay? So just so you know, that's on there. Then, there's also going to be some inverse trig function stuff, working with, inverse trig or inverse tangent of this, or arc cosine of this, or inverse cosecant of that. Okay? So you work with that. Know the fact that sine is right side of the unit circle, inclusive on pi over 2 and negative pi over 2. Cosine is top half of the unit circle, inclusive on 0 and pi. Tangent is right side of the unit circle, not inclusive of pi over 2 negative pi, because those are half. Okay. I will share with you this. The unit circles tomorrow will be covered up. Okay? So they will all be covered. You will have to know, you'll have to go off of memory on the unit circle for tomorrow. Okay? We'll also have some composition of trig functions on the unit. Easy there. On the unit circle by making a reference triangle and algebraic with a reference triangle. Okay? So you'll have to know all of those. Okay? For the next, 7 to 8 minutes, I want to spend on reviewing, and then we're going to get into the next section also yet today and get a couple of those knocked out for today. So, there we go. So when you are identifying the graphs, or when you are graphing, the very first thing that you should look for is the asymptotes. Okay? Because the asymptotes give the function away. Okay? Now, I'm a big proponent of right at 0, because 0 is included in all of the 6 trig functions and their inverses. Okay? So working with 0 is that. Now, on these two are the secant, cosecant graphs because they're parabolic. Okay? Tangent graphs and cotangent graphs are the tipped over waves, the vertical waves, if you will. Okay? So just know that. So on these, I'm looking at 0, and I say to myself, self at 0 on the unit circle, if I reciprocate that value, what do I get? The reciprocal of 1. I'm giving you a softball here. If I reciprocate 1, what do I get? 1. Okay? 1 over 1 is 1 over 1 when I reciprocate it. So that's a value of 1. If I reciprocate 0, what do I get? 1 over 0. And what is 1 over 0? Undefined. Can't happen. So x's is cosine, correct? So what's the reciprocal of cosine? Secant, right? Okay. So secant will have a value at 0. Secant will have a value at 0. So this is secant. What's the reciprocal of sine? Cosecant. Cosecant is not going to have a value at 0. So that one is cosecant. It's all about 0. What happens at 0? Now, if you're graphing these, then what you've got to do is you've got to just find some more points. Okay? Look for where that particular trig value is equal to 1. Look for where that particular trig value is equal to 1/2. Make it easy on yourself. Okay? Because the reciprocal of 1/2 then is 2. And 2 is a heck of a lot easier to graph than the reciprocal of root 3 over 2, which is 2 over the square root of 3. Okay? So you got those two. Same thing on tangent, cotangent. If you'll notice at 0, tangent, cotangent has either a value or an asymptote. So the tangent at 0 is going to be tangent would be 0 over 1. Can I do that? 0 divided by 1. Yeah, that's 0, right? Cotangent is going to be 1 divided by 0. Can I do that one? No. So this one would be tangent. This one would be okay. That looks too much like X, or too much like a Y. Again, all about the asymptotes. Where the asymptotes are at 0 is going to depend on. Okay? What I would like you to do now is I would like you to find me these 4 inverse trig values. Arc tangent, right side, negative arc tangent, quadrant 4. So I'm looking in quadrant 4 where the tangent is negative square root of 3. Y divided by x puts me right there. Negative square root of 3 over 2 divided by 1/2 would be the same as times 2 over 1. Cancel those each other out. Gives me negative square root of 3. Puts me there. I want to say 5 pi over 3, but because I'm dealing with just the right half of the unit circle, I'm going to say negative pi over 3. Agree? Inverse cosine of negative 1/2, looking top half of the unit circle, where my x value is negative 1/2, puts me right there. Nice thing about cosine is straight up, don't have to deal with negatives, and it's 2 pi over 3. Cosecant, or inverse cosecant of negative 2 would be like the inverse sine of negative 1/2. Which would put me right side of the unit circle. Negative 1/2 y value puts me here. So then that would be negative pi over 6. Inverse tangent of 0, right half, y divided by x. 0 puts me at there, so that would be 0 for that. Agree with those 4? Yes, ma'am.
When you were talking earlier about tangent, and you said you can't have pi over 2 or 3 pi over 2.
Negative pi over 2. Yep.
So if there was
You wouldn't have one because it doesn't exist.
Okay.
Yep. Can't have one there. It doesn't exist. Okay. Composition of trig functions. So where on the right half of the unit circle is arc sine positive root 3 over 2. That puts me right here. So I'm looking for here the secant of pi over 3. Secant is 1 over the cosine at pi over 3. So that's going to be the reciprocal of the cosine, which is going to be 2. Arc cosine of the tangent of pi over 4. The tangent at pi over 4 is going to be y divided by x, so that's going to be the same. So that's going to be the arc cosine of 1. Top half of the unit circle, where is cosine 1? And that's at 0. Okay? What's up? Good? Okay. Making a reference triangle, arctangent, right half of the unit circle. Arctangent being negative puts me in quadrant number 4. So I'm going to draw myself a quadrant 4 triangle. Tangent is opposite over adjacent. If I don't recognize that that's a Pythagorean triple, then I can always do the Pythagorean theorem. Define that. So this is the cosecant here then of my theta. Well, cosecant is going to be the reciprocal of sine. Sine is opposite over hypotenuse. So this is going to be hypotenuse over opposite. So that gives me hypotenuse is 5. Opposite side is -3. So -5/3. Same as if it was an algebraic reference triangle. Work the Pythagorean theorem, find which of values are. Okay? So that's for your test tomorrow. So now what I'm going to ask you to do is I'm going to ask you to have out this pink sheet that I told you yesterday you should find. This pink sheet is very important. It is going to have all of the identities that we're going to talk about in this next chapter that we're going to use on a daily basis in this next unit, if you will. I don't really want to call it a chapter, but in this next unit, all of those things on here for us. This chapter, we will shift our emphasis towards more theory and proof, okay? Exploring where these properties or these functions will lead us, okay? Very hard to say like real world things, like this is where you're going to use this in this unit. This is more theory and proof because this is the basics of calculus. Okay? You'll get more in depth into these patterns. They'll take on an even greater beauty when you get into calculus class, your next mathematics class. Okay? So here's the foundations for that. So back when we started trig, back in October, we gave you these 6 identities, what cosine was, sine, cosine, tangent, cotangent, cosecant. We gave you all of those. You pretty much have them all memorized. If you don't, you should. Okay? Then when we started with the unit circle and going through the obviosities of the unit circle, we came up with the hammer. We said sine squared plus cosine squared is 1. Okay? Now, that on your trig identities sheet is number 7. But also on number 7 is some extra ones. How did I come up with that one? What? Subtracted cosine from both sides. Cosine squared from both sides. Okay? Doable. Subtracted sine squared from both sides. Okay? So those are those extra ones there in number 7. Okay? Love it. Well, let's keep looking at the hammer. let's take the hammer and let's divide both sides by sine squared. If I divide both sides by sine squared, excuse me, really what I'm doing is I am dividing all three parts by sine squared. Well, the first one, sine squared divided by sine squared, that's just 1, right? Okay. What is cosine squared divided by sine squared? What do you got? Cotangent squared. Yeah. Because cotangent is cosine divided by sine. So cotangent squared would be cosine squared divided by sine squared. What's 1 over sine squared? Cosecant squared. And that, ladies and gentlemen, is identity number 10 on your pink sheet. Let's do it. Okay? So let's divide everything by cosine squared now. Sine squared divided by cosine squared is tangent squared, yep. Cosine squared divided by cosine squared, that's just 1. 1 divided by cosine squared, secant squared, which is number 11. So yeah. So out of the hammer, we ended up with 5 identities. The 3 in number 7, number 10 and number 11. Okay? Now, what we're building towards is we're going to give you something that looks like this. And we're going to say, simplify it. Okay? Or we're going to give you, I don't remember if I put a, no, I didn't put a really ugly one on there. But later on, we're going to have these like huge, long expressions. And you're going to manipulate them and go through all your identities and all that stuff. And it's going to end up being like 1. And you're going to say, oh, all that work, and it's just 1. And say, yeah, it is. And then after that, what we're going to do is we're going to say, we want you to prove the trig identities. Meaning, we're going to give you a true trigonometric equation. And you're going to take one side and you're going to simplify it until you get the other side. And then what we're going to do is we're going to solve trig equations. So we're going to take, like, instead of an algebraic equation would be like 2x plus 3 equals 0. Well, now you're going to have 2 cosine of x plus 3 equals 0. And you're going to solve it. And that's where we're going with all of this stuff. Okay? So, there are many ways to do these simplifications. Okay? No one way is right. 2 paths diverged in a woods. Okay? Doesn't matter which path you take, because at the end of the path they're going to come back to the same spot. Okay? many ways to get to Mosinee from here. Okay? You're still going to Mosinee. Okay? We're all ending up at Mosinee no matter which way we drive. Okay? So, if I'm looking at my trig identity sheet, I could say, well, number 4 on my trig identity sheet says that the secant of negative t is equal to the secant of t. So this would just be secant of x. Number 1 on my trig identities sheet would tell me that the cosine of negative t is equal to the cosine of t. So this part would just be the cosine of x. And I would still be multiplying them together. And then from way back in trig, secant is 1 over cosine. So then that's going to be cosine over cosine, which means that this identity, or this expression, if you will, just simplifies to be 1. Another way of doing the exact same problem would be, you could say, well, secant is 1 over cosine, so secant of negative x is 1 over cosine of negative x times the cosine of negative x would be cosine of negative x divided by cosine of negative x. Anything divided by itself is 1, so that also gets me to 1. Same way that cosine got me to 1. More than one way to do these problems. Okay. In number 2 here, we've got secant squared of x minus tangent squared of x. Well, one way to do this problem would be to say secant squared of x, according to number 11, is tangent squared of x minus 1. Excuse me, plus 1. Then you still have minus tangent squared of x. And that simplifies to 1. Another way of doing this one would be to say that from number 11, this one. I could solve that for tangent squared of x, and so I'd get secant squared of x minus 1 equals tangent squared of x. So this could be secant squared of x minus secant squared of x minus 1. which would be secant squared of x minus secant squared of x plus 1, which then gets me 1. You'll find that sometimes there's an easy path, sometimes there's a more rocky path. Both of them still get you. Okay? That's what I got for you today. Thanks for playing along. We'll pick up on this on Friday. Tomorrow is your test. You got the 4 things due, plus Friday you've got your steel pipe lab.